B color of blue. So when you look at these normal maps, you see a lot of blue, and you see some greens, and you see some reds, depending on where is that angle of reflection coming out. What is going on to this map? And there's tons of tools that you can use out there that say, here's my texture, give me the normal map. I'll give you a grayscale picture, poof, this is what happens. So now we have these normal textures. I can apply them to my shader, drop it in there, fix it up, and let's look at our image. Our image now knows, because of the normal map underneath it, this should have some different reflections of the light. It's the same exact texture that was on there, but the shader used these extra bits for every pixel to know what the reflection of the light should be. Default diffuse just says, I've got some random numbers in here, so it bounces off and makes it look like a fuzzy object. Specular says that these are all going to reflect exactly like they should. 0, 0, 0 is pretty, or 0, 0, 1 is going to be a complete blue texture map or normal map. But you can play with that. You can mess with all those numbers and get something that looks like this. See if I can rotate this just a bit so you can see some of that shading going on. It looks like it has crevices. It looks like there are divots exactly where there should be divots. Does that make sense? This is the amazing power of what a shader can do for you. Questions?
Insane Bump is a free software that will do what you're talking about, like one of the tools for creating a bump map.
Same Bump?
Insane Bump is free.
Insane Bump.
Yeah, Crazy Bump is a little bit better, but not by much. But it costs like $60.
Okay. Insane sounds better than crazy anyway. So I would go with Insane Bump.
So to make this bump map, you just fed the grayscale image of the texture into software.
Yes. This one I found a website where somebody had done it already, so I could just drag these images in and I knew it worked. You can find a lot of resources for free out there. But theoretically what you would do is say, I'm using Photoshop, I'm drawing my material. Step 2, I draw a picture that has dark spots where I want the crevices to be. That second picture gets computed with either Unity itself or some other kind of tool into a bluish normal picture, which can be added in to our materials. Yes?
So could we give Unity like a grayscale image into that normal map slot and it would compute from that?
Yes. Yes, it does. Unity
sort of like
Unity
a
does
background.
that crazy thing by itself. That was the Fix It Now button. It's like, this is close, but it's not really the image I wanted, and then it'll fix it for you. So you could find different textures and different normals, and they can also be scaled and tiled themselves. So this texture now it looks pretty bad because the crevices are not exactly where the texture said the crevices are going to be. It did the reflections, said there's pieces missing, there's holes and stuff like that, but we can offset it in different ways. So they are slightly different things. Okay, any questions about textures and shaders and materials? Now, if we have time, we'll learn how to make our own shaders, because you can do some super crazy things once you start thinking like this, that an image is just a collection of numbers that I can super fast get them out of these 3 channels. We want to push inside game development as much as we can to the graphics card. This is one way of doing that. Instead of making a super complicated mesh for this object, we made a simple mesh and took a normal map and pushed a lot of those crevice details into the graphics card processing. The more you can do that, the better. So if you want to have reflections of water and waves and some other stuff like that, if you can figure out a way to do it with a shader and come up with some after processing that you do using these numbers from one image, numbers from another image, vertexes, and pushing them together, that's amazing for your game. Super fast to get those realistic graphics. Just to show you what's going on here, let's just search images for a while. This is a good example. You take your super simple mesh with polygons, and then you can do some approximations of it. This is where you add your shaders and your normal map to really turn it into some detailed creviced information, and then you put your texture on it, and it looks really authentic, much more than just a flat mesh of what you'd see over there. What else do we have going on here? The difference between a super high poly mesh and a low poly mesh with a normal map. I'm trying to show you that they're pretty much equivalent. And this is so much faster to process and work with. Okay. This is the one from Wikipedia. I like this picture. 4 million triangles on the left for your mesh, 500 triangles to make a nice simple mesh, but then you use that simple mesh and a normal map to get something that looks really close to the original. Piecing those together is an amazing advance people in computer graphics have made, and we just get to use it. It's really nice. Drag and drop, put that stuff together. Okay, what else did I want to do today? There's the shaders, there's depth. Okay, second thing I want to cover today is animations. There are super complicated animation schemes. Unity has a scheme called Mechanim that says, how can I animate all these 3D objects and ragdolls and stuff like that all at once? We're going to eventually get to that, but you can do some super simple stuff first and just make things move around the screen. So let's see if we can get that to work today. I've got some objects here. I've got a sphere and I've got a cube. I want to animate them. So let's go find a way to do that. Under the window, we want the animation scene, or animation tab. You're like, I already have 7 tabs open. No, we need another one. So we have hierarchy, scene, project, console, inspector. We need the animation tab open. It's an amazing thing. I'm going to shrink it down a little bit. But the animation tab lets us see a timeline. This is at time 0, all the way up to 1 second, 2 seconds. You can scroll out on this, 5 seconds, 10 seconds, 15 seconds. Whoa. And what we're going to do is be able to tell an object exactly what it should do over time. How does this object change? So the object we have chosen right now is our cube. I want to add a curve to that cube. It's like in order to do that, you need a new animation. Let's do that. Let's call it up, down. what type of curve do we want to add? I say that my box has these 4 components. Let's look at the position of that cube. That's what I want to animate, just the position. So I can pop that in. It says, well, the position has 3 elements to it, X, Y, and Z. What do you want them to do over time? At time 0, they are at position 0, 0, 0. At time 1, they are at position 0, 0, 0. So let's change that. Let's change its Y dimension up to 2. So now, at time 0, we are at position 0, 0, 0. At time after 1 second, it's at position 0, 2, 0. So we are good. Let's see what happens. Takes it 1 second. It goes from where it starts and goes up to the top. We change this every time we animate it, and it loops. We can look at our animation, and it loops over itself as it goes. Let's go back to our animation window. And let's add something after 2 seconds. Well, let's change another coordinate and watch what happens. Second 1, second 2, second 1, second 2, second 1, second 2, moves itself up, moves itself over, and it repeats. There we go. Animation. Let's go out to 3 seconds then. Make another spot. Double clicking. I want to go back to spot 0, 0. Then my cube will move up and down and over time. Where could we use this in a game? What kind of things can we do with it? Kill and destroy. Yes, we're doing Dota. What else? I mean, how?
You have even more fake movies
We could have the balls move by themselves. We could have levels where it has something that squashes people if they get underneath it. Just keeps on going up and down, those patterns. Yeah.
You have like things that slice in the ground when you're walking through like a tunnel, you know.
Yes. We could have a ground slicer that just moves. We could do this in front of us. The animation could just happen. You could have, you're pulling out some weapon. This is what it looks like when you pull out that weapon. That wouldn't be a loop. It would happen once, and you'd have to have the script behind it to say, do this animation now. But these animations can just happen. If you think back to Limbo, you could have a gear system that just rotates and moves. So let's see some more details of how it's doing what it's doing. Our animation. This is one perspective for animation. It's called the dope sheet. And you just say, at these times, this is what you should be doing. Other perspective is the curves. You can define it just based on these curves that say, what should my object be doing over time? So let's look at my Y position here. Starts off at 0, goes up to 2, goes a little higher, goes back to 2, and then back to 0. Notice as we play this scene, our movement is not herky-jerky. It's not 0 to 2, over, and then back. 0 to 2, over, and then back. It does interpolation between them. It uses splines. If you ever heard of splines or thought of splines, it is a way to say, I want to make some kind of curve between these points. The harsh way to do it is to connect them up like this. easier